All right, so the second thing we're going to talk about today is arc length. Arc length is a specific portion of the circumference, right? So the circumference is this whole distance around, and our arc length is like a specific. So if we wanted the length of BD, we'd be looking for the length of just that section of our circumference. And so whenever you're talking about arc length, you're always talking about like a piece of the arc. And we're looking at distance, right? So if we wanted to say walk that arc from D to B, we want to know how far we walked. Okay, so let's look at how we find arc length. Arc length, notice it has the equation of the circumference, right? 2 pi r that we talked about in the previous video. The only thing we have to take into account is what portion of the circle, right? Which is this part. How much of the 360 degrees are we looking at? So this letter up here, that's a theta, and that theta is used to acknowledge like an angle measure. So in this case, this angle in here would be our theta. Let's say it was, looks about 45 degrees. We would plug in 45 degrees in there. So that is our angle of the arc. Again, it's all multiplication, so let's go through and try to look at one. Keep that equation in sight. So if we look at determine the arc length of arc BD given this specific circle. And so setting it up, we want to set up our arc length. Let's say AL, arc length, is equal to 2 pi times, what's our radius in this count? Our radius is 5 inches times 5. And then we got to multiply by our angle, right? 70 over 360. And we pulled that angle from right here. That's our theta. And from there, we go through, plug it in our calculator. Make sure you plug it in just like this, where this part, this is important that you put this part in parentheses so that it does that by itself. And if we go through and calculate, we should get that our arc length is equal to approximately 6.11 inches. Make sure you include your units. If they give you units, you should include your units. Again, so just making sure we know how to use this arc length equation and to go from there. Let's look at our next example. I'm going to rewrite our arc length equation here. AL equals 2 pi times r times theta over 360. Okay, so in this case, we want to determine the circumference of circle A. Okay, so think about what it's asking. We want to determine the circumference. So we want to determine how far or how much distance is around the entire circle. And notice we can't just go to our circumference equation because we don't know our radius, right? None of those are given to us. And so we've got to think about what we can do here. So we're given part of our circumference because we're given this angle, or sorry, we're given this distance, and we're given this angle. So we've got to determine how much of the circle that is. And so let's erase that. Okay, so first we want to look at what percent or like what fraction of the circle that 40 degrees is. So the full circle is 360, so 360 divided by our portion 40. What's that get us? That gets us a nice 9, right? Whole number 9. Say if it didn't come out, I'd say round to 2 decimal places, but in this case, it comes out to be a nice whole number. And so we know this 9 tells us that it's going to take us 9 of these pieces to get around our entire circle. And so we got to try to use that, knowing the arc length already. So we know that 9 times 4.19, that specific arc length, is going to get us the entire circle. So in this case, if you multiply it out, you should get approximately 37.71 inches. So we used the piece, and essentially we were like, all right, we know this thing has to go around 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So all we were doing was trying to piece together how many times this chunk fits around the circle.